Hello and welcome back to more Tinkercad. Again, we are going to be talking about circuits today, but we're going to talk about the difference between circuits being in series and things being in parallel, and that would be elements inside of a circuit. So I go down here to circuits again, and I've already loaded up a little thing for us to figure this out with. So I'm going to tinker this. Here it is. So all I've done is I've dropped in a coin battery and 3 LEDs, and I just want to figure out the difference between series and parallel. So we're going to talk about series first. So I'm going to kind of bring one LED into play. I connect the positive to the anode. I connect the cathode to the negative. I hit start simulation, and it lights up with a warning. Oh my gosh, again, you have 3 times as much current. There's 3 times as much electricity going through there as is safe. What are you, crazy? Now, to see this series, when things are in series, that means that the electricity doesn't have to make any decisions. That means that there's only one path through. So if I go from this cathode to this anode, and I go from this cathode to this anode, to the negative terminal, then the electricity leaves here, goes up into the anode of this LED, out the cathode of this LED, across the wire to the anode, in the anode of this LED, out the cathode of this LED, down the wire and into the negative. So there's just one loop, there's one possible path, and when we look, we go, I can't really tell if it's lit or not. So let's grab another. Oh, hey, buddy. Sorry, for some reason it doesn't seem to want. Oh, let's get out of there and just get a new one. I'm confusing my computer. These things happen. So to truly see if this is working or not, let's take this LED, put it right next door, and then we're going to kind of zoom in on it. And if we hit start simulation now, you see, oh, it's slightly lit up. So this unlit one is just for reference, and say, oh, okay, it's slightly lit. And if I look here, I see that I can drag this one over and see that that is slightly lit too. Okay, and they're lit the same amount, right? They're both just barely lit, different from that one. Now, let's put a third one in. What do we think is going to happen? Well, let's see. When I had just one LED, it was so bright that it gave me a warning. Now I'm on, when I added a second LED, I couldn't even really tell if it was lit. Let's look at 3 LEDs. So again, it comes out, the electricity comes out. The positive terminal goes into the anode, out the cathode, into the anode, out the cathode, into the anode, out the cathode, and back into the battery at the negative terminal, and there's only one direction. And if I hit go, nothing. If I take another LED and put it right next to it and zoom in, nope, I got nothing. Look at that. Look at nothing. As I start and stop the simulation, no lights go on. This is called series. And the reason it's called a series is the electricity goes through it in a series. It hits the first light first, the second light second, and the third light third every single time. And you'll notice that there's a huge drop off in power, right? There's a huge drop off in what the electricity can do if it's in series. So now, oh, sorry. Oh, I forgot to disconnect them. Now let's look at parallel. Parallel is a different thing. Let's just get rid of that guy. Oops, keep forgetting to disconnect them. So parallel is when you have to make decisions. So if it's in series, there are no decisions to be made at all. The electricity has only one path. in parallel, what that means is the electricity comes out the positive and let's say goes into this anode. But to be in parallel, that means that there are multiple options. So here, the electricity can go into this LED or this LED. And let's say, hey, well, let's just wire them all up. Why not? Got nothing better to do. Pandemic, stuck at home. Let's just go wire crazy. So in this, the electricity actually has a decision to make. It leaves here and has to decide, am I going to go to this LED or this LED or this LED? And no electricity goes to all three. These are one-way roads, so if electricity goes into this anode here, it will leave this cathode and doesn't loop back around. And just let's start putting the cathodes in. Let's have it go back into the battery. So here we have, I'm just setting it up in parallel. Again, this is parallel, and hopefully by the way I've laid it out, you kind of understand how it got this name, because everything's in parallel. Everything is parallel. And decisions have to be made in parallel. Now, let's start the simulation, and oh my gosh, all three lights light up, and all of them have the warning. Look at this. But notice, when it's just one LED, the number that it gave me at the beginning was 60 something, and now it's 28 something. That's interesting. So even though they are at full brightness, there's less electricity going through than if, let's say, let's stop this simulation. Let's just look, if we look here with, it says 28.5 milliamps. Hopefully you can see that. This says 28.5 milliamps in that first sentence. This says 28.5 milliamps and really only recommends 20. And what happens if I remove one? So now electricity can't get into this one. And it's not going to exit if it doesn't go in, so this wire just doesn't do anything. Now if I hit start simulation and I look, 38.9, it's not 28, it's now 38, and they both have the same amount. And what if I get rid of this one? Again, since no electricity is coming in, none's going to come out, and this wire doesn't do anything. I hit start simulation, and now 61, holy cow. With one, 61.9 milliamps are going through. With two, it was 30s, it dropped down in 30s. It was almost like a half, 2/3, closer to 2/3. And then with three, it was like a third of that. I mean, it's just power. Even though the results, it's not super obvious that there is a cost, because often you'll get kind of similar effects. Often, if I hit all three are wired up, they all turn on and go, oh my gosh, this is like magic power. Well, no, not at all. Less current is going through them, but they still have enough current to kind of do their job. In fact, they have too much current. Current is the actual flow of electrons. That's the electricity. So these are in parallel. A decision has to be made. The other one was series.